Welcome to Brain Vision.
In this question, we want to ask ourselves whether the force is a conservative or non-conservative force. We have, for the first one, is constant multiplied by y square in the j hat direction. So j hat is basically along the y-axis, right? Now if you were to consider what is the work done from a point to another, an arbitrary point from say x, y to x prime, y prime, then what we have to do is to integrate the total force times the direction of the movement that is parallel to our force, which in this case is just dy, right? Since j is in the y-axis direction. So this cy squared dy, and we integrate the y value from y to y prime. Right. Now what this tells us is that the work done doesn't depend on x, and with the same starting and ending points, we will have the same y values, and therefore the final answer for work done would not be affected by any change in the x values. So no matter what kind of x values it takes in between, it would not affect our final answer, and so it can take any path as long as it arrives at the same y value at the end, right? It will not affect, right, the total work done, and so this is a conservative force. On the other hand, we want to consider now a force F equals to cy square, but in the I hat direction, right? So I hat being in the x direction, doing the same thing, to find the work done, this will be f dot dx from x to x prime, which is cy square dx from x to x prime. Now for this case, it depends on the value of y, and what this means is that how y changes will affect the final value of the work done. Say for example, if y is a constant, then we can bring this out to be y naught square times c dx. Right, this integration doesn't care about the path, but y naught cares, right? If you have your y being at different starting points, you will have a different overall work done. Say for example, if you want to move from x to x prime over here, but your starting y, your y naught is at a higher position over here, over to here. If you were to move to here, it will contribute a different amount of work done compared to a smaller value of y, and this will affect, right, the total work done based on which path you take, and therefore this is a non-conservative force.